Okay, this is a pretty tough one. Basically, when we have limits, here, limits as x goes to infinity, it's saying L'Hopital's rule. When you have x is in the base and x is in the power, you want to take the natural log of both sides. That's how we do that. So let's just let y equal this 13x over 13x plus 10 to the 2x. And then if we natural log both sides, remember that powers can come down. That's one of the natural log qualities. It's a very important quality of natural logs. Why we love natural logs. They can do that little trick. Okay. Now, having done that, now we're ready to take the limit. We want the limit's not in front yet. So I'm going to take um, I'm going to take the limit of this as x goes to infinity. Okay, well, what I'm going to want to do, if I plug it in right now, let me just show you. If I plug in infinity right here, and infinity right there, what's going to happen? Well, this will be, 2 times infinity, that's just infinity, times, and this is going to be the natural log of 1. Why? Because remember when we have a fraction, we have powers top and bottom. You just take the highest power top and bottom. That's all that matters. So 13x over 13x is 1. Okay, now what's the natural log of 1? If you check on your calculator, Desmos, here, I'll go to it real quick. Natural log of 1 is going to be 0. Go to your functions. Where is it? There it is, natural log of 1, boom, 0. So that means this is infinity times 0. Now what's that? That's what we call indeterminate because it's unclear. You don't know. How do you know? You might wonder, how do you know what's indeterminate? Well, that's rules in conflict, meaning infinity times anything should be infinity, but 0 times anything should be 0. It's not a real 0, it's just close to 0 actually, right? Because this gets really close to 1 as x goes to infinity, and the natural log as it gets close to 1 gets close to 0. So anyway, it's a really, really tiny number times a really, really big number. We don't know what that really means. It's indeterminate, so we got to change it. So what do you got to do? Well, you got to basically do this. You gotta make it a fraction, and then you've got to put that natural log on the top, 13x over 13x plus 10, and on the bottom, you've got to, I'm going to leave the 2 on the top, you got to put 1 over x. Now, do you see what I've done there? Remember how when we have a 1 over x, we could flip it back up, it'd be x over 1, just be x, be right back where it was. Remember, dividing is upside down multiplying. So if this is 2x multiplied by natural log, then this are the 2. I'm not messing with the 2. It's just x multiplied by natural log, then that's 1 over x divided. Because dividing is upside down multiplying, as we've talked about before, right? So you just, right? Because remember, I gave examples. I don't know if it's worth our time. Real quick. So 10 divided by 2 is 5, right? Just like 10 times a half is 5, right? So that just proves that multiplying by the upside down is dividing, multiplying, it's upside down. So multiplying by x, divided by 1 over x. Now, why would I want to do that? Because now, if you plug in the infinity, oh, yeah, I should say we're trying to get L'Hopital's rule. When can you use L'Hopital's rule? What is L'Hopital's rule? It's when you have 0 over 0 or infinity over infinity, then you can, then and only then, you can take the derivative of the top and the bottom separately. And separately is the key word there. Separately. Not the quotient rule, just top and bottom separately. So anyway, but you gotta first get it 0 over 0 or infinity over infinity. Right now it's infinity times 0. That's not a form by which we can use L'Hopital. We gotta have a fraction. It's gotta be 0 over 0, infinity over infinity. So I take that x and I move it to the bottom as a 1 over x. Dividing by 1 over x is the same as multiplying by regular x. So how's that going to work? Now, if I go to, remember, x is going to infinity. If I plug in infinity, what's 1 over infinity in the bottom? Well, that's 0, right? Remember how 1 over infinity is 0? Right? If they give you 1 millionth of the pi, I'm basically giving you no pi. You have 1 millionth of it, okay? Plug x in the top, infinity, infinity, that's natural log of 1, right? Because you just grab the most powerful term. Those cancels 1, that's 2 natural log 1, which is 0. So I'm getting 0 over 0. So I'm going to go, oh, Lopi, time for L'Hopital. When you get 0 over 0, you can use L'Hopital. So I'm going to go, okay. That's what I wanted. That's what I was looking for. That's what I'm talking about. So come on in here and say, okay, it's time for Lopi. So now, oh, but before I do Lopi, I'm going to go, you know what? This is a terrible, painful problem. I'm going to take 2 natural log, and I'm just going to separate these. I'm going to say, look, I'm going to make that 13, oopsie daisy, 13x um, minus 2 natural log 10x plus 10 over 1 over x. See what I'm doing there? There's 2 in the front. No, you might think you just distributed. No. I use one of the properties of a log. Remember when you have a log of 2 things divided, you can make them subtract it. You can do that. In fact, probably, well, I don't know, we're good. Let's just keep going. So, and I hope the distributing didn't confuse you. It needs to distribute when the natural log breaks up into 2. So the 2's in front and breaks it into 2. It goes 2 places. So, no, why am I doing that? Well, because again, like actually, you know what? Let me do this. Let me just leave the 2 in the front. I don't want, there's so much going on here. I don't want to try and do it in the easiest way for you. So let's do this. Just leave the 2 in the front. Here we go. Okay. So yeah, remember log properties that if you have division in 1 log, that's subtraction for 2. Okay. And it's the log property that also allowed the 2x to drop down. We have those great 3 log properties. Division becomes subtraction, multiplication becomes adding, and powers come down to the front. All right. Keep it on here. Let's keep going. So we have the limit as x goes to infinity. Now, anyway, we already proved it's 0 over 0, so we can do Lopi. So I'm going to go, okay, now I'm going to go equals h, meaning I'm doing, in fact, let me just say, now I'm going to use L'Hopital's rule. L'Hopital. All right, so we say equals with an h. I mean, I'm doing Lopi now. Here comes Lopi to the rescue. Okay, so now because I have 0 over 0, I can do Lopi, top and bottom. So let's make it happen. So Lopi on the top, let's leave that 2 sitting in the front, not doing anything. But now what do you do with natural log 13? Well, remember, for natural log, it's 1 over the argument times the derivative of, because the inside is not a simple x, derivative of the argument is 13, minus, same thing here, 1 over the argument, 1 over 13x plus 10 times the derivative of the argument. What's the derivative of 13x plus 10? It's just 13. Okay, on the bottom, now this is really x to the minus 1. So the derivative is minus 1 x to the minus 2. So notice that was not the quotient rule, was it? I didn't take turns and divide by the denominator squared. That'd be questionable. This was not questionable. This was Lopi, L'Hopital, which means top separately. Did the derivative of the top totally separately and the derivative of the bottom totally separate. Lopi says you can do that whenever you have 0 over 0 for a limit. So I go, okay, now can I clean that up a bit? It's going to be some fancy algebra. This is not an easy problem. This is certainly a calculus problem. All right. I don't know if you're laughing or crying. All right. So now what am I going to do? I'm going to leave that 2 sitting in the front. And then this 13 is going to go to the top. I'm going to get 13, because 13 over 1, right? Over 2x minus, same thing here. It's going to goes to the top, 13 over 1. So you got to be good with fractions. You're going to make it through calculus. You got to know all the fraction rules. Got to be able to handle this. And the denominator, I think I'll just leave it as it is. Okay, so now what? Well, it's just a big mess right now. I really need if I just plug in the infinities right now, it's not going to do anything. That's 0 minus 0. Um, it's not going to go anywhere. What you got is you got to get a you got to combine these with a common denominator. So I'm going to multiply the top and bottom of this one by 13x plus 10, and the top and bottom of this one by 13x. Do you see what I'm doing? I'm making the two denominators the same. That's the only way we can add or subtract fractions, combine them, add them and subtract them, is if we have common denominators. So we have to multiply by the other denominator. So I multiply top and bottom of this one by 13x plus 10. Multiplying, we multiply by the other denominator. So this one goes top and bottom here, and this one goes top and bottom there. Why? Because then the two denominators are the same. They have everything, right? So that'll make common denominator. So now, bring this here. Sorry, I feel like I need to apologize for this problem. This is a really bad one. Okay, so now coming in here, we've got 2 sitting in the front. Oops, I'm in the wrong mode. Come on. Okay, so now what do you have? I'm going to distribute this. This will be, and these guys are going to be over a common denominator of 13x times 13x plus 10. On the top, it'll be 169x plus 130 minus 169x. Let's multiply. Okay, I'm just gonna leave. I'm gonna leave the denominator. Okay. Now what will these? Something nice happens. Boom to boom. Something good. We're gonna get somewhere good. I promise. Hang with me. We're all good times are about to come. So, all right. So what do we have now? 2 on the top times, and this is going to be 130. Well, I guess I will go ahead and distribute this. 169x squared plus 130x over now. Actually, what I'm gonna do, I'm sorry, this guy, he's gonna jump back up here. Remember, because he's minus 1 over x squared. I'm gonna flip him back up. I know it's a lot of maneuvers here. This is gonna become 2 negative x squared over 1. This doesn't make handling. Sorry, I just keep apologizing. 2 negative 2x squared over 1 times. You see that? Because this flipped up and became negative x squared over 1. Remember, we can flip anything on the bottom of a fraction, we can flip it to the top because dividing is upside down multiplying. So dividing by negative 1 over x squared is the same thing as multiplying by negative x squared over 1. Okay, why is that so great? Then these guys can multiply. We have no more, there's nothing more down here, so just skip it. So now we are so close. Something wonderful is going to happen. Has this been a wonderful problem? Okay, these guys are going to multiply. So what do we got? We have got minus 260x squared over 169x squared plus 130x. Okay, great. Now we're ready. Can we let x go to infinity? Yeah, what do you do when you got powers on the top and the bottom? Remember what we learned earlier? Last section thing it was, just grab the most powerful term at the top, most powerful term at the bottom. It's all that matters. So really this becomes limit, x goes to infinity, of minus 260x squared over 169. So it's all that matters. This guy's chump change. You go to infinity, small power terms don't matter. X squareds cancel. So this is going to be just x squareds are gone. Minus 260 over 160. Now careful, that's not the answer. Why not? From the beginning, this was the natural log of y. Natural log of y. So now we have, okay. So we have the natural log of y is minus 260 over 169. You know what I mean? Right? So up here in the first step, remember, whenever we have x is in the base and x is in the power, we natural log both sides. So I did that. I natural log both sides. So don't forget at the very end, you're not done yet. You got one more step. This isn't y or the answer. This is natural log y. So what do you do about that? Do you know? You go e to this side and e to that side, and these cancel out. Remember, e and natural log are opposites. You do e to both sides. Raise both sides to as power of e. Raise both sides. Um, I don't know how to say it. Both sides become the power of e. All right. Um, e to both sides. I'll just say e to both sides. E both sides. Right. Because if they're equal, two things are equal. You can do the same thing to both of them. They'll be equal afterwards. You got that. These will cancel out. So this will be y equals, and there's our answer. You can simplify that a little bit. You don't have to, but I'll do it. I'll divide by 13, top and bottom. So that's actually e to the minus, what is that? 20 over 13. Is that what they said here? E to the minus 20 over 13? Yeah, e to the minus. That's the same thing. It's 20 over 13. So there it is. That was a royal challenge. There we go.